Hi, everyone. My name is Javier Luraschi. I work at R Studio. I'm a software engineer. Thanks for joining this talk on Sparkly R, which is going to cover how to use Apache Spark with R using Qubole's infrastructure. For those that are not familiar with R Studio was a company that got started around 2009 by J.J. Allaire. And the whole purpose of R Studio was to create tools, open source tools that support the R community and the R programming language. Now, since then, we've grown to not just support the R community, but also support the data science and the scientific community in general. And there's many customers of R Studio that use both our open source products, but also our professional products that usually one of the key features of our professional products is that they enabled kind of like more IT-driven features like security and support, as well as collaboration features. Recently, in around 2016, R Studio and myself and other team members, we started contributing to Spark by creating an R interface to Spark with a package called Sparkly R, which we're going to cover in detail in this talk. So just taking a step back, we kind of like cover what is R Studio, company that I work on to support the R community, but we really haven't mentioned what is exactly R or why is R relevant. And to me, when I started working in R Studio, this wasn't completely relevant or clear. But now I feel I can kind of like communicate to you like why I'm so excited about the R programming language. So first of all, like let's think about data science. And me personally, I haven't found a very particular or very rigorous definition of what data science is. But one of the most famous tweets is one from Josh Willis, where he basically defines data scientist or data science as, like a person that is, like very good at statistics and also very good at software engineering, right? It's kind of like this mix of two different disciplines where combined together really give you like a lot of skills to manipulate data very efficiently. So that's kind of like the definition that I like of data science because it's pretty easy to understand. But what is interesting to me, if you were to go to the R project webpage, like the webpage from the R programming language, they basically define R as a programming language and free software environment for statistical computing and graphics. So R, precedes, I think, what we call data science today. But it's kind of like really interesting to me that to see that R itself was designed with computer science, right, as a programming language, and also as statistics in its core. It's a project and it's a language that was designed for statisticians and by statisticians. So whenever we think of data science, one of the strong arguments that I have for using R or considering R is mostly because it's probably the only programming language to my knowledge that was designed for data science. And if you look at the bottom left chart of this slide, this is a count of daily downloads of R packages. And as you can see, this is the usage of R packages, which are made available in the CRAN repository, has been growing significantly for the recent years, right? So this is a chart that I created a few months ago, so it doesn't contain the 2020 data, but like you can see that definitely the R community has been growing. The number of usage of packages is still thriving. So it's still like a very exciting time to join the R community and use the tools that the R community is making available. And the other piece that to me is interesting is that in one of the Use R talks that I had the chance to attend, the way that the creators of R presented kind of like what R is also good at is kind of like this slide that you see on the bottom right, where they present R also as an interface algorithmic interfaces to other programming languages. And the reason is that, when you're doing data science and when you're doing statistics, a lot of the time you want to spend most of the time doing statistics and not dealing with the underlying software engineering details. Back in the day, what they were doing they were abstracting modules on Fortran. Today, what is really relevant, I think, is that we can use R to abstract concepts like Spark or TensorFlow, Torch, or deep learning, and basically simplify them such that data scientists or AI professionals can be the most productive that they can when they're working with their data sets and not have to worry as much on the computer science aspects of dealing with these technologies. So this kind of like brings me back to the origins of this talk, which is we're going to talk about how to do Spark with R using cluster computing frameworks. And I'm not going to present what Spark is. My guess is that everyone on the Data Lake Summit already is familiar with Spark. But as 30 seconds, to remind us of what Spark is, I would describe it as a cluster computing framework for generic data processing at large scale. And basically, Apache Spark is a very well-known project that we can use to manipulate data in our data lakes. But not only that, when we think about mixing it and using it from R, the project that we started, we name it Sparkly R. And basically, Sparkly R is just an R package, but it has grown to be more than an R package. It's also an ecosystem of packages and a community of people devoted to making R and Spark better. So what we have in this slide, we're kind of like showing that Spark at its core enables us to connect to Spark, but also lights off multiple functionality and different packages like dplyr, which is well known in the R community, or tidyr and Broom and many other packages like Parsnip and why not, that kind of like enables them to light up and be used with Spark, and as well, like it allows other technologies like H2O, XGBoost, and MLib to be used from R with Spark. Now, it's worth mentioning that Sparkly R started as an RStudio project, but last year, actually early in the year, we announced that the project transitioned to be part of the Linux Foundation under the Linux Foundation AI umbrella. And so basically, it is an open source project that you can use that is hosted with the Linux Foundation. It enables using multiple technologies for R and many R packages that are well known by the R community. And it also allows you to use Spark with any infrastructure, right? Spark by itself is already a cluster computing framework that runs in many different clusters, say Yarn, Mesos, Kubernetes, or even cloud providers like Qubole, and so on. So kind of like a little bit behind our motivation of Sparkly R, right? And why Sparkly R helps us scale data science. So the way that we think about Sparkly R, it's not really in terms of things that you do directly with Sparkly R, but things that we enable by using Sparkly R with our packages. So the example that we have in this slide is we basically have a dplyr code in the bottom of the slide, and it's saying, it's a very simple example that it's basically doing analysis over the flights, the well-known flights data set. It's just grouping them by month and day, and then there's just summarizing them by creating the average of the departure delay of the flight, and then we filter and the count of the flights that were delayed on particular days that are bigger than 1,000. So the code that is shown below, you can just copy paste it, and it would run on an R console. It's just dplyr code. It's what data scientists know and already familiar with. So that's the data science part. What Sparkly R enables you is to add the 3 lines that we have on the top, which is basically load the library Sparkly R, and then a Spark connect. And again, like you can connect to multiple clusters running Spark independently of their underlying infrastructure. So you can use Spark locally or in Yarn or Mesos, Spark standalone, Livy, or cloud providers like Qubole. And basically what it does, that this line is just connects you to the cluster. And then the next line, what we're doing is we're copying the data set. Now, in most cases, you don't need to copy the data set. If you're dealing with big data sets, usually your data is already in your cluster. So usually you can skip this step. But what is really interesting is that we haven't changed the code below. Like the code below is exactly the same. It's using dplyr and doing data science. And then by adding Sparkly R functionality on top of it, is basically enabling you as a data scientist to run your workflows that were already running locally. Now you can scale them without changing any code. Now, in practice, this is honestly like a moving target. Even though we keep adding packages and we keep adding functionality, there's new, more exciting functionality coming on the R community. So, it's not true that you can just, including Sparkly R and all your R code magically scales. But it's certainly kind of like one of our goals that you as a data scientist don't need to worry about how to scale your code. And, it's our job to make Sparkly R better, such that you don't need to worry about how to scale your data science code, but we can take care of that for you. And one of the things that, I want to make this talk kind of like interactive in the sense that I can show you how to use Sparkly R. And one of the things that we recently announced in 2020 is that a partnership between RStudio and Qubole, where Qubole basically added first-class support for Sparkly R and RStudio, and makes your life really, really easy. So if you want to learn more about this, you can go to either the RStudio blog or the Qubole blog and kind of like find that post where Qubole and RStudio detail like how you can get to use RStudio in Qubole clusters and why not. But kind of like give us some familiarity of how that works. Here, if you're already familiar with Qubole, all you have to do is kind of like log in. And the idea with this particular partnership is that you can pretty much just kind of like start your cluster, which in this case, just to save us some time, I already started before this talk started. But it's just a Spark cluster. And one of the new features that are available, as you can see, is that you can also launch RStudio. And basically, that allows you very easily to create a Qubole cluster. And once you have your Qubole cluster, you can use, obviously, different tools like notebooks and why not. But you can also launch RStudio Server Pro to give you a full access to the range of functionality that is available on RStudio. And it's quite easy. It's a really nice integration. You just need to pretty much click this. And where you would land, you would basically land on this particular page, which is just RStudio running under Qubole. Now, this simplifies your kind of like workflows, because even though you can usually configure RStudio to connect to a cluster and install it on the driver node or why not, some of the benefits in general of like working with cloud computing providers is that you don't need to worry about managing your infrastructure. So certainly it's one way of working with Spark and R, but you can also install Spark locally on your local environment and like have your internal cluster and then install RStudio server and make use of similar functionality if you want to manage these yourself. All right, so this is launching kind of like a Qubole cluster with RStudio, which is quite straightforward. We'll get back to this in a second, but just kind of like wanted to mention that being part of the Data Lake Summit, it's probably likely that you're already using Qubole. So it's something that you can consider using once you have this in your infrastructure. All right, so unfortunately, I mean, there's a lot to cover on like 30 minutes, for a introductory talk for Sparkly R. But I think what is worth mentioning or recapping is that we've been working on Sparkly R since September 2016, where we launched the first version. Back then, it was we named it the 04 version, which had basically support for the basic functionality, right? Like being able to connect to clusters, being able to do basic data analysis with dplyr and machine learning with Spark's MLlib library. And since then, you can keep track of our blog posts and kind of like see a detailed progress of the project. But like since we started with this kind of like core functionality, we've been evolving it to support things like back in the day Cloudera and making it enabled for being used through Apache Livy, which is a proxy to Apache Spark. And later on, we added support for distributed, arbitrary distributed R computations in the '06 release. This basically allows you to run arbitrary R code in each of the worker nodes on your Spark cluster. We don't recommend these for like new or even intermediate users. This is a functionality that is left for very advanced use cases where you have to use something very particular that is only available in R. But then you also can kind of like customize the way that each worker node behaves by using particular R code with your transformations. In the '07 release, we added support for pipelines, Spark pipelines, which it's a pretty great functionality in Spark that allows you to decouple your data science transformations and modeling to something that is agnostic of your data set and even the programming language. So you can basically interoperate between R and say Python or mlib by extracting a pipeline and then letting your Python deployment DevOps team to really deploy that pipeline with production data sets while your data scientists maybe work on a subset or a data set that is just not production. So definitely pipelines add a lot of functionality. We kept improving the machine learning library to have full coverage of the algorithms that mlib support. Then in version '08, we added support for graph processing. And also production pipelines, which it's again a continuation of pipelines, but using technologies like mlib, you can take your Spark pipeline once the model is trained, and you can extract that pipeline and run it on any Java VM aware device, right? So with mlib and the production pipelines featured, you can basically take a Spark pipeline that you train, say, on Qubole, and then extract it to the JVM and say run it on an Android device or on your web server to do kind of like real time, scoring or scoring on your production datasets. Version '09 of Sparkly R adds support for Spark structured streaming, which is kind of a big deal because it allows you to basically process real-time data using Spark with the same constructs that you already know, same data analysis in the case of Spark using dplyr. But it basically allows you to process real-time data in a very, very straightforward way. And the 1.0 release, we basically added support for Apache Arrow, which is a columnar data store that really improves performance significantly on Spark. And we added support for XGBoost, which is well-known machine learning library for training forest models. Version 1.1 added was when we announced that Sparkly R was becoming and is now already part of the Linux Foundation. And we wrote a book with O'Reilly, Mastering Spark with R, that I really recommend if you kind of like, I know that I'm going pretty fast, we only have 30 minutes, but if you really want to take a step back and kind of like learn all these concepts and how exactly Sparkly R works in detail, you can read the Mastering Spark with R book, which is also available on the rinspark.com. And more recently, on this year, we have already 2 releases, which is Sparkly R 1.2, which adds support for the for each package, which is a pretty well-known package in R for doing parallel processing. It also adds support for Spark 3.0, which I'm pretty sure you're familiar with. And the latest version of Sparkly R 1.3 adds support for high-level order functions, Avro, and custom serializers for reading and writing data from R. So again, like this is a lot of content, but I think the most important takeaway from this particular slide is to just notice that there's a lot of like good engineering work that has been put in Sparkly R, and knowing that now it's supported with Qubole, inherently, and RStudio, you have like a pretty great platform for doing data science at scale using R and Spark. So now that previous slide was really like a really high overview of like how everything works without really getting into the details of how Sparkly R works and how you actually get to use Sparkly R. So kind of like what I want to present now is give you a couple examples of how Sparkly R looks in real life, and perhaps give you a good sense of how is that different from Python or other technologies that support Spark. And I think what I want to do for this particular slide is I'm going to switch back to Qubole. And we're just going to use RStudio. And basically what I did is pretty much I copy pasted this slide, which is going to walk us through many of the functionality that we mentioned without being able to cover absolutely everything. But it should give us a good sense of how to use Spark and R with Sparkly R in a proper Spark cluster. So what I did is I pre-created a notebook. This is kind of like similar to Jupyter notebooks, but I would argue richer and better. And basically, the concept here is a concept that in general we can trace it back to literate programming from Dr. Nutt, that basically argues that you're better off doing data science and in general programming if you mix prose, which is what we have here, is just text, with your code, right? So this allows you to kind of like build reports that are self-explanatory because you can actually explain them with text, while still keeping track of your code and making them able to be executable. So in this case, we're just creating a plot for the cars dataset, empty cars. And you can see that we have a plot here, but the really nice thing is that you're mix and matching both like the prose and the code as you would expect when doing data science. So all I did was pretty much create this particular notebook. And then we have a few things that we need to run when we get started by using Sparkly R. So the first one is we need to load the library. So we're loading a Sparkly R. It's basically getting loaded. Now, the next step is once you load Sparkly R, if you were running this on your local machine, which you can also do, you would have to install Spark locally. So you would have to run Spark install. Now, since in Qubole you have like a turnkey ready solution for you to do data science at scale, you don't need to install Spark at all whatsoever. So you can the next step, what you want to do if you're using Qubole is you want to connect. And again, like you can connect in different ways. If you were working locally, all you have to do is say connect Spark connect master equals local. Or if you were using Yarn or other technologies, that's where you change. But since we're using Qubole, all we have to do is connect by saying Spark connect method Qubole, and that would basically connect us, and we would get a connection to Qubole, which, as you can see, after you connect, you get connection to the connection becomes available also in the RStudio connections pane. So you get a quick glance of the functionality on the data sets that are available to you on your Spark cluster. In this case, it looks like Qubole already has a data set pre-seed for sales data by default in this cluster, or maybe we loaded. I honestly don't remember. But regardless, like if you're using Qubole and in your organization, you would have access to all the data sets that you have available. And then the next thing what we want to do in this case is I want to show you how to use the copy to command. This is a command that you wouldn't have to run, because if you're working with big data, you usually don't have to copy data into your cluster. Like the data in the cluster is already available, because otherwise it wouldn't be really big data. But a lot of times it's just useful to have like copy, like perhaps like a reference table or things like that. In this particular case, I already copied the data set, which it was made available on the connections pane. And you can take a look here, and it's pretty much just the empty cars data set, but you can also open it, take a look at that particular data set as well. And one of the things that is worth mentioning is that you can also quite easily, from the connections pane, just open the Spark user interface, which a lot of times is useful to troubleshoot your data science workflows, right? So, like most of the time if things go well, like usually you're just working directly on RStudio, but like if for some reason like a Spark job is taking longer, you can very easily switch to the Spark UI and have a really close look at what things are happening and how things are executing. All right, so we kind of like copy a data set. So now what we can do is, we can do something straightforward with dplyr. And again, like I feel like this particular example showcases the power of dplyr and in general the power of R for data science. What we're doing is counting the records, and it's just literally all you have to do is say count and then the records on your table. And in this particular case, actually, we have 32 records, which is quite straightforward. It's the empty cars table that everyone knows. But if this was a large data set, you can make use of multiple worker nodes and whatever, and still run that computation in parallel. In fact, like if we were to go back here and we go to jobs, like we should see that the latest one is not 72, but like it should be, 47. And if we were to re-execute this code, we can validate that it's running on Spark mostly, because we can see the job numbers being executed on the background for us. So let me just see if that here, and then I'll refresh this page. And then, yeah, basically what we get here is, let's see, it should be, we get like a new job of basically the execution statement that we just run. So you can see here that we have this particular job, and you can, if you want to, you can also look at the particular SQL query that was being executed, and see some of the details of that particular job. Well, this is a streaming query. You can click SQL. All right, so like this should be pretty familiar to all of you if you're working with Spark or if you're working with Qubole infrastructures. And a few more interesting things that we can do, as I mentioned, we can make use of all the machine learning MLlib library that is available on Spark. You can also use H2O with extension XGBoost and even train deep learning models at scale. But for now, for this particular talk, I just want to focus on a very simple linear regression running on Spark. As you can see, the syntax is quite straightforward. All we have to do is ML linear regression, and the output almost looks like a standard output from running a linear regression locally on R without Spark. But you can see that same kind of like pattern. Like this is not running locally on R. It's actually executing. As you can see here, we're running a linear regression, and it's actually executing on Spark. But as a data scientist, you still are mostly working with R. Things look very familiar. You can make use of formulas and concepts that are pretty familiar and useful in the R world. And now, just for comparison, if you're already familiar with SQL, you can also run SQL queries. The way that we do that on the R ecosystem is with the DBI package. So we can say db get query, and that executes you just basically that query and retrieves the results. As you can see here, you can look at all your data sets and why not. And yeah, this combination of data analysis and modeling like covers 80% of the use cases of Spark, right? I mean, a lot of the times we want to basically do data analysis and modeling with like different type of statistical models at scale. And honestly, like all the ML functions, and there's so many more, and using dplyr or DBI to execute SQL queries, it really gets you pretty far just with this functionality. But not only that, like as I mentioned, there's a lot of functionality in packages that are available for Sparkly R. We have a GitHub repo where github.com/RSpark, where many of the extensions are available for graph processing, as I was mentioning, for doing TensorFlow record creation. Recently, with a team member in RStudio, Yitao Li, which is the current contributor on the Sparkly R project, developed an extension, Sparkly R Flint, for time series processing. So again, like in order to enable kind of like this functionality, one of the things that Sparkly R enables is just creating arbitrary calls to the Spark API. So here, what we're executing low-level Scala code that gets executed from R. It's not something that new users or even intermediate users usually care about, but if you're building extensions, you can also make use of all the Spark packages, and we try to simplify them and make them available for the R community. Now, something interesting that just happened quite recently is we announced a new version of Sparkly R. I didn't have the chance to add it to the slides, but I wanted to share it with you all. And it's the Sparkly R 1.4 version adds support for weighted sampling, tidy verbs, and robust scalar, and even support for GPU processing with the Rapids integration. But in this particular talk, I just wanted to show you how to use tidy R verbs with Sparkly R, which is quite a new feature. If you're an R user, you would probably love this because you're already familiar with tidy R. And it doesn't require you to relearn yet another package. And again, the great thing about Sparkly R is that you don't need to relearn kind of like data science again to scale it. You can use the packages that you know and love. In this case, TidyR. And what we're doing here is we are using the pivot longer function on TidyR to basically kind of like pivot. You can think of it as a pivot table or pivoting your data set. And yeah, it's executing on Spark. And as you can see here, we converted basically our column-based data frame into a row-based data frame with keys and values, where each key became one of the columns, and each of the values in the entry also became a value in the actual pivoted table. So yeah, again, there's so much more to learn on Sparkly R, but I think just to close on this, definitely, like you have a great platform in Qubole and other cloud providers that allows you to use data science and Spark with R very easily. So take advantage of that. And just to close, I want to kind of like leave you with a few resources that you might find useful to kind of like learn more about Sparkly R and in general Spark and R. So the first one is there's a landing page on sparklyr.ai hosted by the Linux Foundation, where it doesn't have a lot of content, but it has all the right high-level content for you to see which are the customers that are using some of the customers that gave us permission to like showcase them in the landing page. You can read a little bit about the architecture. We give you resources to the documentation. Some of the contributors of the Sparkly R project are RStudio, Databricks, and Qubole. And so it's kind of like your landing page to learn more about Sparkly R. If you want to share it with a colleague or someone else, kind of like help them learn more about Sparkly R, that's a great resource. And the other one, if you want to be more serious about using Spark and R for data science, you can read the Mastering Spark with R book from O'Reilly. If you don't want to buy it, all the content is also freely available in the rinspark.com. I personally enjoy reading books a bit more than kind of like reading stuff online, but the content is already free. So it's really, we're really kind of like one of our jobs is to make scaling data science the easiest possible that can ever be done. And so this type of resources and, developing philosophy that we have with Sparkly R is really trying to accommodate the new user that is kind of like learning Spark and growing into data science. All right, well, thank you so much. If you want to learn more about this particular event, there is the hashtag Data Lake Summit, I believe, or the Slack group. I'm planning to hang out in the Slack group during this time. So if you want to talk to me about something particular about Spark or Sparkly R and R, feel free to find me there. And I would definitely encourage everyone to subscribe to the blogs.rstudio/AI blog. That's where we make our new announcements of Sparkly R versions, and also new technologies like Torch or TensorFlow and MLflow and why not. So definitely you can keep track of Sparkly R if you subscribe to this particular blog. Thank you.